I'm Sergey, and I'm really glad to be here and to talk to you all guys and to work with you in these 2 days. Before I introducing the company, HS Analysis, which is subsidiary of Bin Holding, which are completely in my private hand. I would like to go to the challenges where we, with our colleagues, Vitaly and Lukas and other colleagues from my team, identified, and just to introduce you some thoughts from our house to let you know in which direction the company will be developed in the direction of automatization of labs. And now, dynamics. So this is the first challenge: rapid adaptation to change of the changing requirements. We have always changing requirements and how to adapt techniques mostly and easily. The next is quality maintenance is important point after commissioning new processing and established and adapted processes and synergies between project partners to see how many partners are there involved in some projects and how should be all this stuff done by the standardization in laboratories. This is the main point here. Integration into an external environment. Yeah, of course, what is the integration? How deep do we do this process establish there? And what's about our own and external environment? This is always the topic that we talked about with our colleagues. Then, of course, know-how is an internal issue. Is this that or not? Mostly what we got, yes, it is. And how to start collaborations, real collaborations over the many years and see what's happened there. And this is the next issue. Maintaining the process. What's about when the employees leave the company? For example, we got a case device for production of glass and deforming of glass, 1,200 degrees and so on. And we developed a tool together with the company. And there was a guy, only one guy, which was able to work with this machine. And after this optimization of different parameters, which was done completely by AI, and it works. We never thought actually that it will work, but it worked there. And then we got a solution there, and then we integrated it, this prototype further and further. And at the end, this guy, Argan, was retired, and then some calibration should be done. He wasn't anymore there. But AI cannot do this, yeah. Because of that, we have always to take care about the whole process and integration, something and automatization and of some workflows. And at the end, such stuff as retired and calibration of the machine or something is then broken. You cannot think about this in general. If you think about this, then you say we do not need AI because AI cannot solve this in general. Yeah, this is a little bit interesting. Yeah, TCO reduction is always the point and really important from our opinion point of view. And we have always investment, development, integration, operation, and maintenance. And then we have to see should we save cost on the development, then we will get some difficulties, for example, in the maintenance or integration. Or should we invest into development and then we save something maybe in the integration? And I do not know really correct answer for this, but I think this is actually our expertise that we're doing in our consulting because we're starting all this development and stuff like this. This is really important for me personally. Then operational safety measures is an issue, and data exchange and cross-system connectivity. Okay, we will listen to these topics today more and more, I guess, all together. We're working on this. Yeah, and now let me introduce you a little bit our HSA, so HS Analysis, and we're doing do-it-yourself deep learning techniques. We developed the software, and I was this weekend in Berlin, Bayer working with us in Charité. We did 3 integrations on 2 days. And the doctor in ophthalmology in Charité Virchow, they were able to create her own deep learning model with 127 images on eye tumor directly into the lab after the integration of this software. So we did it on one computer and without integration in like Linux and Kubernetes and so on. But firstly, we have to check exactly what has been done today and try to solve this problem before we then integrate it into the whole system. Yeah, we are 25 engineers located in Karlsruhe. We have 2 offices, our research center in the northern part of Karlsruhe, and in the center, our software development and hardware development. And we're active not only in image analysis, which we described on our website. You do not see a lot of information on our website in general. We are experts as well in molecular analysis and multispectral analysis integration, and now we're preparing solutions for robotic integration. Yeah, and here, this is interesting. This is actually a device that was built by us completely. So we do some prototyping. Some companies want to measure something, and then they can check how should it work with some classical methods combined with AI. And what we're doing, we're thinking first AI, and then as engineers, and we're developing some own productive infrastructure. Then we going to lawyers and doing some patents together and selling our license. For example, this is our business model in general. And these are we guys sitting in our offices there. And here you can see, for example, this is so this is in a lab where we're working on display production. So this is not only about medicine. So we transfer the technology from the medicine on in a lab for quantum dots preparation, for example. And this image, you can see kidney of a human and how we annotate. And then we use these annotations for deep learning, for example, and then they are able to detect glomeruli and something what is then for development of such drugs. We have something to check on kidney, and that's how we do it with deep learning. In preclinical and clinical direction. This is again where we are active in biology, smart industry, material science, and pharmaceutical sector. And digitization of medical infrastructure. So we not only analyze some images, we prepare these images as well. For example, slide images, we have a product which you can use for manual scanning of microscopy images, or we have some OEMs for the integration on the microscope, and we have 2 microscopes with us, and then you later could see how we do it in the automation then. Well plates and multi-channel fluorescence analysis here, and we're using, for example, DICOM as a standard here for some PET CT images there. And for example, this is one of the standards which is already established, and in the laboratory what we want to do is exactly to establish CELA2 as a standard everywhere. In every laboratory we want to bring this standard into it, and now we are on the way. We have some expertise and so on, and now we would like to integrate this CELA2 standard there in different laboratories. Microscopy infrastructure of our solution. Okay, you you have your microscopes here, for example, or slide scanners here. Then you produce data with this. You have data storage. Then you have analysis on our services or on working station, or we are in the cloud as well. If you need this because of the guys which are using our software, then we integrated internet, intranet, or just local station there, and you have your access point and connection to this, for example. This is in general how it was built. We were using C++ firstly, and we're using C++ for integration on the devices. Then we use C#, for example, and now because all the deep learning stuff is in Python, and we're using Python, then a little bit C# as well, and C++ for the device communication. And our solution is built in front end with React, which enables us integration on Windows as well as Linux server, and working with Docker technologies and Kubernetes, for example, or just Windows and then let it run on a machine. Yeah, some examples. Zebrafish analysis. Video annotations of label-free data in videos and segmentation of atrium and ventricle in fully automated way, for example. Yeah. The next thing, okay, quality control of meat. You have meat, you have your Raman spectroscopy and microscopy, and then what we're doing, we collect all this data and we connect the data from Raman spectroscopy, and we're using all these proprietary formats of different, and we are really focused on integration of proprietary formats into our system, and then transfer it to the standard that we established there for the deep learning analysis, and then we're creating then AI and got results, yes or not, for example. Yeah, and the process get your data, classify data, generate report, documentation. You see this here as well, and this is exactly the point where we would like to integrate Sila 2 into the standard workflows with all our customers that we have. And for example, in the microscopy, you prepare the slide, generate unique code. As you see, then you digitalize this data using the unique code. Then you do naming conversions. After that, it's going to our analysis system, as I told before, and we're writing report, and then you see it in a list. Okay. Yeah, this is name convention that we're doing. Firstly, we scan the QR code content, and this is the format that we established there in automated way, because we do not want to work manual, and all the issues that we create there in CVUA, Chemie Veterinary Untersuchungsamt, what is it called in English? Yeah. But you know this is going to be done that way, and then we have automatically created some microscopy images and connected them with the right deep learning modules, some apps like components, and because deep learning is not able to analyze everything, it should be focused on one topic, and then it is able to do this topic exactly good, but there is no possibility to generalize. We're working on it like in research, but with federated learning and so on, but it's not so easy to bring this solution to the market today. Yeah, actually, when you're using your infrastructure, what we got, if you're creating your own new device, it's really difficult to integrate it into the market. What we said, okay, we do some OEMs, bringing this on the microscope, and then automate microscope to create this and to collaborate and there to analyze. And yeah, as I told before, we have 2 microscopes with this system. This is like the software, and here you can see meat, histological slide of a meat, and you have someone who's sitting there, and AI is as an assistant and helps to identify here something which is not okay, and then we will get to report, okay, take care about this, and the production should be stopped on that way. And biotechnical direction, we're working on stains of, for example, in ice cream with algae. And they are bioreactors which are producing the cell cultures and at the end the algae. And what we're working is in miniaturization of this process and the quality control on this. Because we think when you control the quality, then you can go into the production and pre-culture and as well into the processing. This is how we do, and there are a lot of sensors, and we try to bring all this information from the center combined and analyzed. As well as I told before, some device that we built here to input some materials or drugs into the device and then to see the autentication of the material in general. And completely with deep learning. So we integrated the same stuff what Bruker was done with principal component analysis, but its principal component analysis was built on the existing data. And in that case, we predicted the concentration of unknown stuff, which we didn't use for training, and the system is working. To predict some concentration of unknown ingredients without knowing this. Optoelectronic materials, LED production, as I told before, here can you see some microscopic images and Z-stack and then calculation of volume. Actually what we're doing here is with deep learning automation of prediction for the fabrication conditions. Before you're doing this experiment, it's really it's not so cheap, each experiment, and of course you wanna predict it before and then try with the parameters that you got from your AI, and then after that doing your experiment in the laboratory. This has happened there. Another project, we developed a hardware and software for the peptide production of the peptide arrays and predictions of epitopes. And this is the device here. We did it with our partners from KIT. It was a great collaboration, and then lithographic printing of nano signals. This is exactly the aim here. And then we're using deep reinforcement learning, which is known from robotic, to predict the epitope sequence in unsupervised way there, and then see what is the prediction of epitopes and structures within this. We're working here with Amble together, for example, and I believe in such products. Okay, we have Illumina, which already, or other small companies, and this is another product with some advantages and disadvantages. Or hospital patient monitoring solution, HSA track, event-based cameras. You don't see the frames like we know. We see the movement of the people and the direction, and then we train the artificial intelligence without using convolutional neural networks. We're using spiking neural networks exactly for the event-based data analysis. And then we can see, okay, this is a human being and is male and is nervous, for example. We're using it for analysis of tracking as well of buying structure, or how you say, motifs when you're going buying something in Aldi, for example, and to track the people. As well as this part, combine different techniques, bring it on the one basis, and then analyze. So photoacoustic signals, videos, OCT, and 3-channel fluorescence microscopy. It's really interesting because we're using AI to create some, but it's not so fast process, to be honest here, to create some quality that we need when we do not have this, and then extract something from that and then classify using active learning methods already implemented in the software. So it helps. Diagnostic on bone marrow biopsy. Here I would like to say that the combination of different data is really important for the analysis at the end. And we have here clinical data, pathology data from cytopathology data, and flow cytometry, which are always different proprietary formats then, and then we combine it in our solution. And at the end you got your prediction there, with all the cell lines, and which is then used, for example, in Erlangen. Back to the challenges we talked about before. The solution to these challenges that we think is the standardization and with the focus on SELA and ANML. For correct data exchange, and of course BPMN for proper modeling of the workflows. And as you see, our software is actually what you saw before is exactly here, but there is a strong connection to the integration layer, for example, and device layer, as you can bring it in the combination with the topics I told before. And of course, we have a business layer here, which should be integrated in all these layers then. Then examples of automation with different standards. We have semi-automation integration of some semi-automated workflows. We're using microscopes, and then we're bringing some something on the device to shift X, Y, and Z level then, and then analyze the glomeruli we talked before, and this happen in real time. And then through the microscope, you see exactly the detected glomeruli and can analyze and track through your ocular or bring it on the monitor, for example. And the next step is then what we done is integrated some hardware devices, which is like OEMs, put it on the microscope for the automation. As I have here an example. Here there is a tool which is then printed and then put on this in the car for the automation of car driving functionality. Okay, how does it work to train deep learning without coding? This is viewer of a microscope image from Leica, I guess, and we have here possibility to see 3 whole slide images, and after that we got the automation from these images to that fully quantification of the cells in that case. How does it work? Okay, we get data, we clean, prepare, train model, test data, and improve. Then stop this, validate, and get your FDA certification and use it in maybe in your process. Okay, that's how we collect the data with the pen or with the mouse then. Then we have the system where you, without coding, use something that you want to train. You click here, that's it. In the end, everything that we've done is already automated. And what you do there, you check a lot. You see what's going on, how to check different parameters, different techniques, because we implemented hundreds of deep learning techniques, and then you can create all the combinations, manual or automatically. And then once you got your model, you just integrate the model here and let it run. And then you got all the data quantified. at the end you have this. Yeah. Okay, this is unsupervised, for example, this lung tissue. And what we are able here to do is to separate the tumor tissue from non-tumor tissue. But in general, it doesn't work that way that we got as results with supervised learning, which is really painful work, but we do not have any chance now, today. But I believe in this technique, in unsupervised deep learning, that will be someday there and will be used really intensive. Yeah, at the end you have your image and your data. And always what we want to see is we're creating heat maps to see the activation functions, and we called it explainable AI now, but it's just a marketing gag, and all the modules that are created. So from neurospheres, volume detection, over fluorescence analysis, Ki67, something in neurology, or hypoxia detection. So we have hundreds of these modules already created for different type of analysis methods. At the end, you don't want to work a lot with the software. You want to just click here and then process all the data within this project, or do it automatically. If you do it on robots, for example, then you program something, some rules for processing of something here, and then it's happened in milliseconds. Then it depends on how much images and so on we're using. For example, we're tracking all the receipts or in delivery process of new something which is delivered, then tzaka or milk and so on. Yeah. Or check is the box completely closed or not, should be shifted somewhere or not, doing some stuff on robotics. Yeah, at the end you have your quantification and the interpretation of the quantification, and this is really important. All this happens offline, because there are a lot of companies who are doing it online. Okay, this is okay, but we're doing it offline. And of course, we can integrate it in online. We have strong partnership with Ionos here, but of course, we're working with Azure or Amazon. Yeah. And this is, for me, a really interesting part, federated learning and in combination with the cloud integration. Do you know what is called federated learning? Have you heard about this? Yeah, okay. Federated learning. Okay, you train your models in a hospital A, several models in hospital B, and C, they're completely separated. And then you want to combine all these models, the power of the data. And mostly what done before, you take the data with you and then train a big model. The data and then train a big model. Now what we're doing, we take the models or the mathematic models before the model was built without taking the data somewhere, and train a big model. Then we send it back, and they using the anonymous, without using the data from B and C, is able to use the deep learning models based on their data directly on the devices. This is what is for me really interesting. Decentralized systems. Yeah, and to bring this technique into laboratory automation, it would be good. Of course, we take care about standards and regulatory aspects here, and I'm working with industry Chamber of Commerce in Karlsruhe together, and working with TÜV Süd and DEKRA together, really coming together, and from with Brussels and Berlin to establish, for example, in AI Act, the standards for the integration of deep learning into the industries. These are some customers that we have, and thank you for your attention. If you have some questions, please let me know.